So you did it. You built out your shiny new microservices architecture. It's beautiful, it's scalable, and now something's broken. Or worse, it's just slow, and you have no idea where to even start looking. Sound familiar? Well, in this explainer, we're going to wrangle that chaos. We're talking distributed tracing in Spring Boot using OpenTelemetry and Jaeger, and by the end, you'll know how to turn that debugging nightmare into a story you can actually read. Let's get into it. Okay, let's kick things off with what I like to call the microservice murder mystery. Because honestly, trying to find a bug in a distributed system feels less like software engineering and more like being a detective in some noir film where everyone's a suspect. You know the feeling, right? You get that dreaded ticket. The checkout process is slow. So you start digging. You check the payment service logs, nothing. Inventory service looks totally fine. User service, nope, clean as a whistle. You're bouncing between like a dozen different terminal windows trying to stitch together what one user did. It's exhausting, and most of the time, you find absolutely nothing. And that right there is the fundamental problem. Back in the monolith days, if something was slow, you had a single crime scene. You knew exactly where to look. But with microservices, oh man, a single click from a user can set off this insane chain reaction across 10, 20 different services. The issue isn't one bad service, it's the conspiracy between all of them. See, this is where your good old grep on a log file just falls apart. Trying to manually match up request IDs across all those services, it's like trying to reassemble a shredded document during an earthquake. It's impossible. This is where distributed tracing swoops in to save the day. It's the technology that automatically connects all those dots, giving you a beautiful visual story of a request's entire journey. What happened, where it happened, and crucially, how long every single step took. Now, to really get why tracing is so powerful, you have to understand where it fits. It's a key part of what we call observability's holy trinity. So super quick, you've got three main things. First, metrics. These are your numbers, your aggregates, CPUs at 90%. We're getting 500 requests per second. They shout, hey, something's wrong. Then you've got logs. These are discrete events. User 123 failed to log in. They tell you what happened in one specific place. But traces are the magic glue. They tell you where and why something is slow by showing you the entire end-to-end story. They connect the what's wrong from metrics to the what happened in the logs. Okay, so how does this work? Well, everything in the world of tracing boils down to one fundamental building block, the span. Just think of a span as a single step in the journey. It's one piece of the puzzle. It could be an HTTP call, a database query, you name it. And it's simple. It just has a name, a start time, and how long it took, the duration. Right, so if a span is one step, then a trace is the entire journey. It's the collection of all the spans that belong to a single request, all linked together in order. This is what gives you the full, complete story, from the initial click all the way through every service to the final response. So, how do all these spans get connected across different services? This is the secret sauce. It's called context propagation. When a request first hits service A, it gets stamped with a unique trace ID. Think of it like a passport. Then, when Service A calls Service B, it passes that passport along in the request headers. Service B sees the passport, knows it's part of the same trip, and does the same thing when it calls the next service. It's literally like passing a baton in a relay race, keeping the entire journey connected. Okay, this all sounds amazing, but for a long time, there was a huge problem. Every vendor, every tool had its own special proprietary way of doing this. It was a mess. But thankfully, the industry got together and created a universal standard that has completely changed the game. Before OpenTelemetry, or OTel as everyone calls it, you were completely stuck. You were locked in. If you instrumented your code with, say, New Relic's agent, you could only send data to New Relic. If you wanted to try out Jaeger, sorry, you'd have to rip everything out and start over. It was awful. OpenTelemetry fixes this by giving us one single vendor-neutral standard, a common language for all our observability data. And this really is the core idea. Instrument once, send data anywhere. You write the code to generate traces one time using the OTel standard. Then you can just flip a switch in your configuration to send that data to Jaeger or Datadog or Honeycomb or wherever you want without ever touching your application code again. It gives you complete freedom. All right, theory time is over. Let's get practical. You're probably thinking, this sounds complicated to set up. Well, with modern Spring Boot, it's almost laughably easy. Like, you're not going to believe it. If you've ever had to mess with Java agents in the past, just forget all that pain. With Spring Boot 3 and beyond, it is literally 2 steps. Step 1, add a single dependency to your pom.xml or build.gradle. Step 2, add one line to your application.properties file to tell it where your tracing backend is. That is it. I'm not kidding. And this is the little piece of magic right here, the Spring Boot Starter OpenTelemetry dependency. When you add this, Spring's legendary auto-configuration just kicks in and does all the heavy lifting. It sets up the OTel SDK, it finds all the right instrumentation libraries, and it wires everything together for you behind the scenes. So for that one dependency, what do you actually get? So much. Straight out of the box, it automatically traces every incoming web request, every outgoing HTTP call you make with REST template or web client, every single database query you run through JDBC, and it automatically adds the trace ID to all your logs. You get all of this without writing a single line of instrumentation code yourself. It's incredible. Okay, so our application is now pumping out all this incredibly rich tracing data. But data is useless if you can't see it, right? That's where a tool like Jaeger comes into the picture. Jaeger is our visualization tool. It's the evidence board for our murder mystery. And looking at the Jaeger UI for the first time, this is the real aha moment. It takes all that trace data and turns it into this beautiful waterfall diagram. You can see the entire request flowing from one service to the next, and you can see exactly how long each part took. See that one really long bar right there? Boom. That's your slow database query. You just found in 5 seconds what used to take 5 hours of digging through logs. And this goes way beyond just simple HTTP calls. For databases, it's an absolute game changer for spotting nasty performance killers like N+1 query problems. And for message queues like Kafka or RabbitMQ, it will automatically link the service that produced the message with the service that consumed it, even if they're hours apart. You get true end-to-end visibility even in complex, asynchronous systems. Okay, I know what you're thinking. The number one question is always, what's the performance overhead? It's a fair question, but honestly, with modern systems, the impact is surprisingly small. And the key is sampling. In production, you don't need to trace every single request. You just trace a small percentage, maybe 1%, maybe 5%. This gives you more than enough data to find problems without slowing anything down. The overhead is almost always negligible. All right, let's wrap up with a few quick pro tips to make your life even easier. First, give your custom spans meaningful names. Validate payment is way more useful than just process. Second, add important business context to your spans as attributes, things like the user ID or order ID. It's invaluable for debugging. Third, be smart about your sampling and production. And finally, for any real production setup, look into the OpenTelemetry collector. It's a separate service that can receive, process, and forward your data, making your whole setup much more robust. So, to put a bow on all of this, distributed tracing is so much more than just another monitoring tool. It's a complete paradigm shift. It takes you from the world of guesswork and frantically searching through logs to a place where you can scientifically see and understand exactly how your systems are behaving in the wild. Look, every request flowing through your system is telling a story about its journey, its struggles, its successes. With tools like OpenTelemetry and Jaeger, you finally have the ability to sit down and listen to those stories. So the only question is, are you ready to hear what they have to say?